Hi, and welcome back to Science in VR, brought to you by OzGrav. OzGrav is the ARC Center of Excellence for Gravitational Wave Discovery. Today, we're going to explore bigger than big with SciVR. We'll start here at our SciVR menu, scroll down until we get to the icon that says bigger than big. Either tap your screen or hit the clicker in your cardboard VR headsets. In this scene, we will focus on comparing the size of some celestial objects. We have placed the objects all around you in this scene so that you can compare their size side by side. If you start at the Earth and look to your left, you'll see the Earth compared to the largest planet in our solar system, which is Jupiter. If you continue to look to the left, we have placed Jupiter next to the Sun. Now, the Sun is so big at this scale that it fills up your entire screen. Even though the Sun appears very large compared to planets such as Jupiter and the Earth, it is actually fairly small compared to other stars in our universe. For example, here we've placed it next to a blue supergiant, which is one of the larger stars in our galaxy. However, this blue supergiant holds a secret. At the end of its star life, after its supernova, it will leave us with a pulsar, which is this very tiny spinning stellar remnant we see here next to the Earth. You can take a moment to read about the pulsar and then learn more about it in our star lab. Now we've traveled to the stellar interior. Here is where we will work to understand a little bit more about the processes in the core of the star that drive its evolution through its life cycle. Here you can see that the gravitational force that will want to pull in a star will actually be balanced by the radiative pressure from the energy generation in the center of the star. The pressure at the core of the star actually drives the process of fusion, in which smaller elements fuse together to become heavier elements with the byproduct of energy. Here you can click through your periodic table and see how larger and larger elements are created from smaller ones. These fusion processes will create elements as heavy as iron. At that point, the gravitational pressure is no longer strong enough to fuse any heavier elements. This is the point at which the stars will start their supernova processes. One of the remnants of the supernova process is that pulsar we see. Now we're going to head back home. Now we will take a look at an additional resource that you can use to further engage with this content. If we go to our Science in VR page, that's scivr.com.au, we can go ahead and scroll down, stopping here to take a look at the recorded talk for more information, or scrolling a little further down until we get to the Kids Fun Sheet. If we click on the one that says Bigger Than Big, it'll bring up this fun sheet with word search, crossword puzzle, and maze. Thanks for joining us, and we'll see you next time as we learn more about science in VR.